In this video, we will evaluate a few more limits at infinity. So the limit as x approaches infinity of 2x plus 1 divided by the square root of x squared plus 1. Now our previous intuition had been if it was a rational function, which this is not because of the square root term, we would take the largest power of x in the bottom and multiply by 1 over x to that power divided by 1 over x to that power. So let's go ahead and see if that same intuition can apply. And the key observation is to just know which term is going to be the largest, the square root of x squared. So it looks like the largest power of x in the bottom is going to be approximately, say an x to the first power, because it's a square root of x squared. So with that in mind, we are going to multiply by 1 over x divided by 1 over x. So it's multiplying by 1 in a fancy way. So this will be the limit as x approaches infinity. And when that 1 over x distributes in the top, that will be 2 plus 1 over x. And in the bottom, what we would like to do is somehow get that 1 over x inside the square root. So a key observation to make is that if x is a positive quantity, then x is equal to the square root of x squared. Now in this problem, we have the limit as x approaches infinity, which means it's a positive quantity. So we can rewrite the 1 over x as the square root of 1 over x squared. So the 1 over x can become the square root of 1 over x squared. And when you multiply together two square roots, you multiply what you have underneath. So that 1 over x squared needs to hit each term underneath the square root. So 1 plus 1 over x squared. Now before continuing with this problem, let me make a small observation. If x is a negative quantity, then minus x, if x is a negative quantity, then x, which is negative, it might be better to write it this way, is minus the square root of x squared. And just to give you an idea of why this is true, think if x is minus 1. So you'd have minus 1 as your x value, and the square root of minus 1 squared by itself would be the square root of 1, which is 1. And minus 1 is not equal to 1, which is why you need this extra minus sign, which is out front. So if it had been a limit as x approaches minus infinity instead of x approaching infinity, we would have then had to introduce a negative sign into the problem. So that's a very important observation. So now let's go ahead and apply our limit laws. We can take the limit in the top, divide it by the limit in the bottom. In the top, we'll break it up into the limit of the first function, 2, plus the limit of the second function, 1 over x. And in the bottom, we're going to take the limit, put it inside the square root, and when it's inside the square root, we'll take the limit of the first plus the limit of the second. And at this point, we can now evaluate each of these limits individually. The limit of 1 over x as we approach infinity is going to be 0, as is 1 over x squared. The other two remaining limits are limits of a constant, so you just get back that constant. So 2 over the square root of 1, which is 2 over 1, and the value of our limit is the number 2. So let's evaluate one more limit as we approach infinity. And my intuition here is that if you think about what's going on as you approach infinity, you're going to end up with, say, something that's getting really large, so approaching infinity, minus infinity. And we really have no meaning that we can associate with infinity minus infinity. It turns out that can actually be any number we would like. So what we are going to do is use a common technique that we've seen in a previous video. We're going to say it's a limit involving a square root term where it's a square root of something plus or minus something else. So we are going to multiply by 1 in the fancy way where we multiply by the conjugate over the conjugate. So we are going to multiply this by the square root of x squared plus 2x plus x divided by the square root of x squared plus 2x plus x. And what this is going to allow us to do is in the top, when we FOIL that out, remember it's the difference of squares formula. We can think of it as being something like an a minus b times a plus b. So a squared minus b squared. So the square of a square root makes it go away. So a squared would be x squared plus 2x minus b squared, which is x squared. And in the bottom, we're going to have the conjugate expression from above. And this is working out wonderfully because the x squared over x squared has canceled. And now note that if we look at what remains, 2x divided by the square root of x squared plus 2x plus x, this is very similar to the previous example. So what we can do is think about what is the largest power of x in the bottom and multiply by 1 over x to that power divided by 1 over x to that power. And the largest power of x in the denominator would be corresponding to that square root of x squared term or just the x term, x to the first power. So we are going to multiply by 1 over x divided by 1 over x. When we do so, our numerator becomes a 2. And in the bottom, we are going to distribute the 1 over x through and have it hit each term. So x times 1 over x is 1. And recall from our previous example that when we put that 1 over x against the square root, we are going to write that as the square root of 1 over x squared because we're dealing with a positive quantity for x. So this will become underneath the square root 1 over x squared times x squared plus 2x. 1 plus 2 over x. And we now apply our limit laws. We get the limit of what's in the top divided by the limit in the bottom. Now in the bottom, we're just going to go ahead and take care of combining together a few limit laws at once. You can take the limit of the first times the limit of the second. And in that first limit, we can plug the limit underneath the square root and then break it up over the sum. And the power of applying our limit laws is that we've now broken this up into 4 individual limits, but they're all limits that are simple for us to evaluate. So the limit of 2 over x in the bottom is 0. The other limits are all the constants. The limit of a constant is that constant. So the value of this limit is 2 over 1, which is the number 2. And once again, from a big picture perspective, a very important observation to make is that we may have to apply multiple techniques to the same problem. Here we went back to this old technique of multiplying by the conjugate over the conjugate, which simplified the expression so that we could use this newer technique of finding that largest power of x in the bottom and multiplying by 1 over x divided by 1 over x. So remember, limits are going to require patience and perseverance. So don't be afraid to try some type of algebraic manipulation just to see what will happen.